Now I'm going to talk about some of the more modern file formats. The first is SVG. This format is more self-contained than other image file formats and can be more technical to produce and edit because of it. SVG stands for Scalable Vector Graphics. SVG was originally designed for vector graphics only, but has become a metafile format. As I explained earlier, metafile means that it can handle both vector and raster images. SVG is a web-only file format. It's fully supported by all web browsers, as an especially popular format for graphics displayed on mobile devices and responsive web designs that reflow text and objects according to the size and orientation of the screen. SVG images are XML files that are dynamically rendered at runtime. Runtime just means when they're displayed on a web page. If you don't know what XML is, don't worry about it. Just know that because the format uses XML instructions to render the graphic, it means that you could actually create and edit a graphic using a text editor alone. This is not for the faint of heart, as these XML instructions can be very complex and requires deep knowledge of the SVG implementation of XML. SVG supports interactivity, which allows dynamic web experiences, animation, which only a few other image file formats support. SVG supports integration with web technologies like HTML, CSS, and JavaScript. And SVG enhances accessibility of websites, meaning that persons with disabilities have easier access to the content through special features built into SVG. SVG files that are all or mostly vector objects render very quickly. SVG natively supports all of the basic color models and bit depths, but it has no inherent limitations on this, like other file formats, because it can inherit color models and bit depth from its parent elements dynamically at runtime. That means that you can use an external CSS file to control these elements in an SVG file. All other graphics file formats contain instructions for rendering images that are set in stone and have no awareness of or communication with other elements on the web page or website. Best practices for using SVG are as follows. There is no need to rasterize vector artwork as in other formats, which can handle raster images only. With SVG, you can leave them in vector format. It will render quicker than a raster file on a web page. Use settings in your SVG editor to allow the SVG to scale correctly to fit its container while maintaining its aspect ratio. You can also control SVG dimensions in CSS or directly in the SVG with percentage-based values to ensure that it adapts to different screen sizes and resolutions. Use tags within your SVGs to help read aloud applications called screen readers, which use an artificial voice to read what is on the screen to the user. Use an external CSS style sheet that controls the appearance of all objects on the website to also control the appearance of SVGs. Normally, image files are stored in a separate location on the web server outside of the HTML file for a web page. To take full advantage of SVG's features, you should embed SVGs, code and all, directly into the HTML file. This is especially important when the SVG file needs to be manipulated or interacted with via JavaScript or CSS. This gives you much better control over SVG elements compared to when they're loaded as separate image files.